Imagine handing a kid a giant box of mixed Lego pieces with zero instructions and saying, "Sort these however makes sense to you." No picture on the box. No right answer. Just go. That, in a nutshell, is unsupervised learning. And it's one of the coolest tricks in AI. Hey, welcome back to AI in 5. Yesterday, we talked about supervised learning, where the machine learns from an answer key. Today, we're flipping that completely on its head. We're taking the answer key away. So here's the setup. In supervised learning, every example came with a label. This email is spam. This one isn't. This photo is a cat. This one's a dog. The machine learns by checking its guesses against the right answer. Easy enough. But what if you don't have labels? What if you just have a giant pile of stuff? That's where unsupervised learning steps in. The machine looks at the data and tries to find structure on its own. No teacher. No grades. Just patterns hiding in the mess. Let me give you the classic real-world example. Imagine you run a coffee shop chain. You've got data on 10,000 customers. What time they come in, what they order, how much they spend, how often they visit. You've never sorted them into groups. You wouldn't even know where to start. Are there 5 types of customers? 3, 12. So you let an unsupervised algorithm loose on the data, and it comes back and says, "Hey, I found 4 natural groups. Group 1 comes in every morning, orders the same latte, spends about $6. Group 2 only shows up on weekends, brings friends, orders pastries. Group 3 is the afternoon laptop crowd. Group 4 pops in once a month for a treat." Nobody told the machine those groups existed. It just noticed that certain customers behave similarly, and it clustered them together. That's called clustering, and it's probably the most popular form of unsupervised learning. Now here's the wild part. There's no right answer. The algorithm could have found 3 groups or 6, depending on how you set it up. Different groupings can all be valid. It's not solving a problem with one correct solution. It's discovering structure that was already there, waiting to be noticed. This makes unsupervised learning amazing for discovery. You use it when you don't know what you're looking for yet. Scientists use it to group genes that behave similarly. Streaming services use it to find clusters of viewers with similar taste. Banks use it to spot weird transactions that don't fit any normal pattern, which is huge for catching fraud. There's another big use too, compression. Stay with me. Imagine you've got a photo that's, say, 10 megabytes. An unsupervised technique can look at the image and go, "You know what? Most of these pixels are basically the same shade of blue sky. Let me find the patterns and represent this image with way less data." Same idea, smaller package. That's how a lot of modern compression works under the hood. Same trick works with words and ideas, by the way. Remember those embeddings we'll talk about later in the course? They come from unsupervised learning. The machine reads tons of text and figures out, on its own, that king and queen are related, that Paris and France go together. Nobody labeled any of it. So here's how I want you to remember it. Supervised learning is like studying with flashcards. Question on one side, answer on the other. Unsupervised learning is like walking into a library where nothing's organized and figuring out, these books seem to go together, and these over here are a different vibe. You're not being told. You're noticing. The trade-off, of course, is that without labels, you can't grade the machine the same way. You can't say, "You got 80% right," because there's no right. You have to look at what it found and ask, does this actually make sense? Is this useful? That's where human judgment comes back in. Quick recap. Unsupervised learning finds patterns without labels. Its star move is clustering, like sorting customers into natural groups. It's used for discovery and compression. And there's no single correct answer, just structure waiting to be noticed. Tomorrow, we're cracking open something a lot of folks have heard of, but few really get. Neural networks, explained in plain English. See you tomorrow on AI in 5.